So let's debrief the think about it. So the think about it asks us whether these two figures are congruent, and this connects back to what we did yesterday. Yesterday, we heard that two figures are congruent if there's a series of rigid motions that can map one figure on to the other. So my task here was to figure out if there's one way or some way to transform this figure so it ends up on top of this figure. Here's how I did this. The first thing that I had to do was I had to decide which one of these shapes was going to be my pre-image and which one was going to be my image. It didn't matter which, because all I'm trying to do is demonstrate that I can map one figure onto the other. I know that this needs to turn all the way upside down, so I think that I'm going to have to do a 180-degree rotation. So I'm going to start by doing a 180-degree rotation of this first shape. So when I perform that 180-degree rotation about the origin, I'm just going to apply the rule that I know, which is that the sign of both my x and my y coordinate flip. And then I'm going to plot these points, and see if I have successfully mapped my pre-image on to my image. So take a look here. I did my rotation, but it looks like my figure has not aligned onto the final image yet. I know it goes off the graph a little bit, that's okay. But it does appear that my shapes are now in the same direction, so I am going to be a lot closer now than I was when I started off. So now I just need to move this figure onto this one. I have to slide it up and over to the left. So the way that I can do that is with a translation. And it looks like if I move my shape up by 1, 2, 3 units and then over by 3 units, I will end up on C prime, my actual C prime here. Notice quickly that these both have C prime notation. I can up this to now be C double prime, B double prime, A, E, and D double prime, since I know that it's going to take me 2 transformations to get here. So I'm going to add that translation vector that I just calculated, -1, 2, 3, +1, 2, 3, into my table, and I'm going to double check that my image points that I get by doing this by hand in my table match up with what I see on the graph. So here are the final image points that I got after I performed this translation, and I can just double check those across on my graph. So A double prime should be at 7, -4. Let's check on here. A double prime is in fact at 7, -4. I can check all of these other points, and I have done this correctly. This reinforces that same big idea from yesterday. We're going to write it down again because it's so important, that two figures are congruent if there's a series of rigid motions that can map one figure onto the other. So as long as you can demonstrate that there's a series of rotations, reflections, or translations that will map one figure onto the other in whatever order, it doesn't matter, then the two shapes are congruent to one another. So now it's your turn to try this out. So you have two different triangles here, and you need to describe two different compositions of transformations, two series of transformations that will overlay one shape onto the other, that will map one triangle onto the other. So it doesn't matter whether you start up here or down here, right? But you need to find that series of transformations. Start off by labeling all of your triangles the same way. So let's call these vertices A, B, and C, and we'll call the corresponding points A, B, and C as well. You can fill in the prime notation depending which one you choose to start with as your pre-image and your image. Make sure you add in that notation to help denote which one is which. So independently, take the next 3 minutes to come up with a series of transformations that will map one of these triangles onto the other. You should be using the table of coordinate values the same way we've practiced, as well as the graph to help you do this. Teachers, please set the timer for 3 minutes. Get started silently and independently. So there are multiple ways to perform a composition of transformations that lands one shape onto the other. So I started by using my upside down triangle as my pre-image, and I realized it needed to flip around. So I started by rotating it 180 degrees, which gave me this shape, and then noticed that I need to translate it to get it to land on the final image. So you can see that I did my work in my coordinate table, and then I made sure that my points here matched up with my final image point. So that's one way to do it, was through a rotation of 180 and then a translation. Take the next 3 silent solo minutes to find another series of transformations on the other graph that also will map one shape onto the other. Please use the same naming conventions where you land A, B, and C, but you can switch up which shape is the pre-image and which shape is the image if you would like. Teachers, please put 3 minutes on the timer. So for my second set of transformations, I realized that I could do multiple reflections in addition to a translation to get to my image. So this time I started with this bottom triangle as the pre-image, and I reflected it up, then over the y-axis, and then eventually translated over to get my final points. Again, you can see that in my paper. Multiple ways to do this problem and to do it correctly. Just like yesterday, you're about to transition into independent practice time. You have student helpers who will circulate to help you during this time. In your work, I expect to see things on the graph showing your intermediate steps, and also a table of values and coordinate pairs that will help confirm whether your answers are correct or not. You will have an exit ticket at the end of this time. I am super excited to see your work on Monday when I get back. Good